Today we're gonna speak about Python modules. So when we want to do something, for example, we want to call the function print, well, we don't need any manipulations to do that. Python sort of knows what to do, but there are many other functions of Python which are not included when you simply load your Python beat in console or beat when you execute a script. And for these purposes, there are a number of Python modules which can be used. You just need to import them. And I'll give just a few examples of Python modules which we're probably going to use. The module time, which is well, it's related to different time-related functions. For example, if you want to schedule something to execute at a certain time. The sys module, which provides access to some variables used and maintained by interpreter. For example, if you want to use the command line arguments while running your script. The OS, operational system module, various features related to your OS, like if you want to run a certain other program from your Python script, or the math module, which includes different math functions. And this is what I want to use as an example to show how we work with modules. And also, we actually will be using some functions from these modules. So, in order to use a math module or any other module, you need to import that. So you can do import math. So now you can start using functions from this module. And Spider gives you these hints here, so you can see, okay, well, I'm trying to type sqrt square root, and this will be a function I'm going to be calling. I could do it in actually in IPython console, but alternatively I can save it as a script and run as a script. Okay, so sqrt obviously prints the square root of a number, and I just want to emphasize that this is not the only way to import a module. You can, in fact, do the following. You can type from, then the module name, and then import, and import a certain function. For example, you could use from math import sqrt, and then you can run just this without the math prefix, because you imported this specific function, and you can call these function. However, if you want to call, well, let's say exponent, if you want to run it, right, it's going to give you an error because you imported only sqrt and you didn't import the exponent. So in order to import the exponent, you need to do it separately. So you can do the following. You can do from math import star, and then it will import all the functions of the math modules, and you won't need to use the prefix. You can use the exponent, you can use the natural log, and so on and so forth. Well, this is not a good style, so it's typically when you import a module, you want to, keep it, but there is a way to keep it shorter. So you can do import math as m. And then you will be using your functions as m.log2, and it will be shorter to write, but yet quite convenient, still quite convenient to call. So there are, well, speaking of the math modules, there are a bunch of math functions you could think of. Of course, you can simply get help on the math module, and it will tell you what it has in it. And in particular, all these constants, well, the infinite, the not a number constant, well, the pi constant, tau and Euler's number, all the sine, cosine, square root, and so on. So well, everything pretty much you need to do with operations on real numbers, well, you can find in the math modules. Let me give you just some examples. Okay, let me import math as m, right? And then I can do m factorial. This is, of course, this is something we've been implementing, but of course it's implemented. Many of the functions which you could think of are already implemented, so you can learn how to use them and use them. So m e will give me the e number, m pi will give me the pi number, while m x will give me the exponent. Let me can do m x of m e, or I could do m log of m e, which would be more fun, right? Or I can do log 10, or I can do, let's say, trigonometric functions, m cosine, well, let's say 30, and let's see what's going on. Well, obviously, this is 30 radians. This is not 30 degrees. There is a function to convert from degrees to radians, again, in the math module. So m radians of 30, and if I do cosine, m cosine m radians of 30, that should give me, well, oh, that's well, I should rather pick the sine, I think. Yep, so that gives me 1/2. Obviously, it doesn't give me exactly 1/2, but very close to that. So many other more advanced things like error function, and so on and so forth. Well, one thing I want to emphasize that the math module is designed to work with real numbers. So if you do something like math sqrt -2, it will give you an error. And in order to work with complex number, you need to import CMath. And then if you do CMath sqrt, where C obviously stands for complex, then you'd be able to take square roots from the negative numbers and getting these imaginary results.